Okay, so just a quick example here of components of vectors. So basically splitting the existing vector up into horizontal and vertical components or parts. The example is a toy rocket being launched 75 degrees from the ground and traveling 70 meters per second for 4 seconds. Basically, how high is the rocket? So if we, oh rats, okay, there it is. So this will be my vector. 70 meters per second, and there's the ground and 75 degrees, and then the height essentially is this value that we're looking to find over here. So when we look at this, I hope you can see that we ended up with a right angle triangle, and ignoring the rest of the question, this looks like a pretty simple trig question. I have 75 degrees, I have 70 over here, I have an h value here, which I'm trying to find. And so going back to what we saw back when we were talking trig, this is the side which is opposite the 75, and this is of course the hypotenuse. What we saw before was that sine of an angle will always be equal to its opposite over its hypotenuse. And so in this case, sine of 75 will be equal to the opposite, which I called h, a little confusing I suppose, over the hypotenuse, which was the 70. Now if you wanted to, you could convert the 70 meters per second into a distance. I'm going 70 meters per second, or the rocket is going 70 meters per second for 4 seconds. The number 280 meters would work nicely here as well. Eventually we want the height to be in meters, so making that switch early on is fine. I'm going to do it after, obviously. And so we rearrange this. It's 70 times sine of 75. And then basically we need to punch that into something that can do some math for us. And my calculator tells me that's 67.6. Again, approximately. Whoa. Let's try that a little bit better there. 67.6 meters per second. So that's the portion, if you will, of the velocity that's headed in the upward direction. And then, well, we're not interested in the other one. So h right now is representing the upward direction. It's not actually the side that I'm looking for. And so the height is, we've traveled 67.6 meters per second for 4 seconds. Okay, so that ends up being 270.4 meters. And that's the height of the rocket 4 seconds after its flight begins. Now, if we had tried it the other way using the 280, maybe I'll switch this just to show that it would have been fine. So recognizing that we're going 70 meters per second times 4 seconds, which is 280 meters. So essentially the rocket has traveled 280 meters at, or in that direction. And then at that point we have sine of theta, or sine of 75 again, sorry. Sine of 75 will be equal to the opposite. Now h actually represents the height, divided by the 280. 280 times sine of 75 is my height. And luckily, when I punch this in, I get the same number, again, approximately 270.4 meters. Okay, so really, this first section, all we're looking at is taking the existing information to form our diagram. Because I should have hidden this. And from it, establish what the horizontal and or vertical components are.